Welcome to this comprehensive exploration of Python and Asyncio. In this journey, we will unravel the complexities of asynchronous programming, from demystifying the fundamentals to mastering the intricacies. Get ready to embark on a deep dive into the world of Python and Asyncio. Asynchronous programming is about parallel execution, freeing up the CPU to perform other tasks while waiting for I/O operations. Imagine traditional synchronous programming as a single progress bar moving linearly. Now, visualize asynchronous programming, multiple progress bars moving concurrently. This is the essence of async in Python. At the core of Python's Asyncio lies the event loop, a virtuoso orchestrating the execution of coroutines. Picture the event loop as a bustling conductor directing the flow of tasks. Coroutines, represented as musical notes, seamlessly enter and exit the loop, harmonizing to create a symphony of asynchronous operations. While the benefits of asynchronous programming are profound, it introduces its own set of challenges. Picture these challenges as hurdles on the async track: race conditions, deadlocks, and the infamous callback hell. Navigating this track requires understanding and strategic solutions. To master asynchronous programming, let's navigate through more intricate examples. Imagine juggling multiple tasks simultaneously, each with its own rhythm and tempo. This complexity is where Python's Asyncio truly shines, effortlessly managing parallel execution and optimizing performance. Let's take a deep dive into the event loop, the maestro of asynchronous Python. Zoom into its core, revealing the intricate dance of coroutines and tasks. Witness how the event loop manages the flow, orchestrating a seamless performance of asynchronous tasks. As we solve the puzzle of asynchronous programming, observe the pieces fitting together seamlessly. Python and Asyncio are intricately interlocked, creating a powerful synergy. Unravel the complexity, and you'll discover a robust solution for handling asynchronous tasks in Python. To simplify your journey into asynchronous Python, here are some practical tips. Visualize them as tools in your coding toolbox: effective code structuring, strategic error handling, and debugging techniques. These tips will not only enhance your understanding but also make your asynchronous code more manageable and robust. Decoding the event loop requires a closer look. Zoom in further, revealing its intricate components, coroutines, tasks, and callbacks. Witness the seamless interaction of these elements, showcasing the elegance and efficiency of Python's asynchronous programming model. As we navigate through the complexity of asynchronous programming, here are some strategies to guide you. Visualize them as beacons illuminating your path: efficient error handling, optimizing performance, and structured coding practices. These strategies will empower you to master the art of asynchronous Python. In conclusion, we've embarked on a comprehensive journey through the intricacies of Python and Asyncio. Armed with a deeper understanding of asynchronous programming, you're now equipped to tackle complex tasks with efficiency. If you found this information valuable, don't forget to like, subscribe, and share your thoughts in the comments below. Happy programming!